Okay, so what I'm gonna do now, I'm going to review some of the questions that you missed the most on the midterm. The first one was order of operations. I don't know why students are still missing this question. So let's start. The first thing you need to focus is inside the parentheses. Remember pandas, right? If I write pandas, if I write this way, you have to remember that multiplication division is an OR, depending on who comes first from the left side. That's where students make the mistake the most. So here, first you have parentheses, and inside the parentheses you have an exponent that you need to resolve that first, okay? So let's do, and please always do step by step, and clean work also, organized and clean, okay? So let's erase this. So I repeat everything, don't forget, 4, and then 3 cubed is 8, 8 minus 5 is 3, and 3 squared is 9. So I'm going to put times 9 here, and then this way, all right? So I noticed some students did this subtraction here first. Remember, you have multiplication. You need to do the multiplication first, not do the subtraction, okay? So again, let's solve that. 4 times 9 is 36, and you have here 3 minus 36 is going to be 33, right? So I have 16, 2, and then 33 plus 5. I had some students subtracting 16 minus 2, that's 14. That's wrong. That's wrong. Why? Because you have here a product. You need to do this product first, okay? Make sure you get this question right in the next midterm. We're going to have again midterm number 2, and this question is going to be there again. So make sure you get that one, okay? And I'm sure it's going to be on the final. So 16, you do the product first, it's going to be 66 plus 5. Now 16 minus 66 is going to be what? 50, and 5 is going to be negative 45, okay? 16, that's 50, negative 50 with plus 5 is negative 45, okay? Let's go to the next question that many students missed, was finding the slope of a line. Here, x minus equal to minus 1. So that means x is always negative 1. It does not depend on y. There is no y here in this equation. So it's independent. For any value of y, x is always going to be negative 1. So if I want to graph that, negative 1 is here. This is the x-axis. This is the y-axis. So that means the line is vertical. Okay? Vertical line. So what is the slope here? Well, if you look at the equation of the slope, y2 minus y1, x2 minus x1, you know, the slope is the change in y per unit of x. But in this case, x is not changing, it's always the same. So that means that this denominator here is going to be 0. So a number divided by 0 is undefined. So the slope for a vertical line is undefined. So please, and you have to write down undefined. Okay? Now the other equation is y equals 3. Y equals 3. Okay? So y is always 3, independent of the value of x. So in this case, if I were to graph that, I have here y, x, 1, 2, 3. 3 is here. So y is going to be a constant. So it's flat, it's horizontal, right? In this, yes.
Number 1, isn't it 87?
Is what?
87 times.
87.
Yeah.
Well, let's see, 3 minus 36, oh, here's negative. Oh, thank you for telling me that. So now I have a product of negative 2 times negative 3, that's going to be positive here. So let's change the solution, right? Very good, thank you. So let's see now. 66 with 16 is going to be 82 plus 5, 87. Great. So that's, you see, you need to pay attention in every moment, right? You always mess up sometimes. Thank you for letting me know. So let's continue here. I was saying that when you have y equals 3, it does not change with x, right? So it's a constant, it's a flat value. There's not going up, not going down. So the slope here is going to be 0, all right? So if you look here on the equation, change, there will be change in x, but there is no change in y. So the numerator here is going to be 0. So 0 divided by a number is always 0. So we have slope equal to 0. Is that okay? Okay. So let's erase this and move on to the another question that a lot of students made was the stepwise function, graphing. So what is a stepwise function? Well, it is a function that has two different behaviors in this case, right? One behavior is for the domain of x less or equal to -1. Okay, so let's graph that. So -1 is right here, right, for x. And we can, so that means this here is the border, right? Is the place where there is the change. If x is greater than -1, y behaves as a constant, right? It's a constant value, -2. What is y equals -2? Is right here, -2. So it does not include -1, so I'm going to have to have here an open circle, right? Open circle. And it goes horizontal all the way there, all right? Now, for x equals to -1 and below that, the function is going to behave differently, right? Now y is going to depend on x, and it's going to be equals to 3 times x. How that's going to work? Well, what is the first point? Is -1. When I plug in here -1, 3 times -1 is going to be -3. So that point starts right here, -3, okay? So it's a solid point here, so I make it solid. When x is -2, if I plug in here, 3 times -2 is going to be -6. So -4, -5, -6 is here, so I have another point equal -6. So this is a linear equation. It's going to be a straight line, so 2 points is enough, so I can draw my graph going this way. So you see, that's why it's called stepwise, because there is a step, there is a gap here between this point and above -1, okay? Any question about this? How many of you missed this question? Let's see. Okay. Do you understand now? Okay, so try to practice this again. Go to YouTube links and review other examples of this to make sure you got, okay? First, you need to define the domain for each function, right? For each step of the function. This is one function, but each step behaves differently for different domains. Sometimes you might have 3 different domains, 3 different behaviors, okay? That's also a step function. Next, write absolute value equation. So now here, this is a typical example that you can show up on next midterm and also maybe on the final, is They give you a function, you need to recognize the function, and you need to write what that function is. So when you see a v, you should right away think about absolute value function, right? What is the basic absolute value function? F of x. This is the basic one, right? If I were to graph this one, I would write like this right away, okay? So the slope here is 1, so that means this is 1 and 1 right here. It's a v and 45 degrees v, okay? If I introduce 2x, for instance, what's going to happen is now this slope here is going to change. It's going to be 2, so I'm going to have a point like that. So the v now is closer to the axis, right? So that's what's happening here. The first thing you need to figure out is what is my slope? This v, if you check the slope, if you go here and here, you're going to see that x here is 1 and x here is 3. So this gap is 2, so I have 2 here, and this gap is 4, so 4 divided by 2 is 2. So this slope here is 2, so you need to have a 2x, okay? Now, it has shifted to the right. How much it has shifted to the right? 1, right? So if I'm going to shift this to the right by 1, so at 1, it needs to be 0 at 1, but the slope is 2. If I put something like this, when I make x equal to 1, 2 times 1 is 2, minus 1 is 1, so it's not 0. I need to have a 0 there. So I need to have a value of 2. So that's, when I just shifted this graph here from 0 to 1, this is going to be the function, okay? Now, the function has come down by 4 units. How can I do that? Then outside the bars, I need to put -4, so I can bring it now down by 4 units, okay? Is that okay? So you guys understand how to build this. You have to start from here, then you insert this slope, 2, then you need to make sure that at this point, when it has shifted to the right, you're going to get 0. Look, when x is 1, 2 times 1 is 2, minus 2 is 0. So you got the function equal to 0 at this point. And then you bring it down by -4. If the v was up, you had to add 4 instead, or whatever number it is, okay? Do you understand this now? So try to redo this same problem again, okay? And make sure you understand each step of it, okay? Okay. So let me erase this. Absolute value inequality, another question that many students fail to get it right here. The first thing you need to do here is to get rid of this 5, okay? Move 5 to the other side, and then when you do that, you get x3, and then 2. 5 becomes positive, so you got 2 here now. Now, you need to remember that there are always 2 solutions, right? A positive and a negative. So make sure you draw a line so you know, to remind you that you have 2 solutions. Still, a lot of students got only 1 solution, okay? You're not going to get any point for that. So x, -3 greater than 2 is the positive one. Then you have to remember the negative one. Please remember to put the parentheses. It's very important. okay? Because this is one expression. It's not, isolated. So here I can bring 3 to the other side, so x greater than 5. Now here, I'm going to distribute this negative. It's going to be negative plus 3. Then 3 goes to the other side. Again, it's going to be negative 1. Now comes another point that students fail to do is to flip this sign when you multiply by negative 1 on both sides. So you flip this sign and then you have x less than 1. So here, if I were to graph this, I would put 1, 5 here, open circles, greater than 5 and less than 1, okay? If I were to do interval notation, sometimes interval notation is required, would be negative infinity here to 1, or 5 positive infinity, okay? It's important to learn how to do interval notation as well. Now, this question, I don't know why, many students also miss scientific notation, okay? So the first thing I can do here, I could simplify 9 and 3. That's going to make 9 divided by 3 is 3. 3 times 1.2 is 3.6, okay? Now, let's check the numbers here. If I have, this is negative, I could convert all these negatives into positive. So I'm going to bring this up. So I'm going to have 10 times 10 cubed, and this is negative here, comes down. It's going to be 10. So I cancel this 10 with this, so I have 3 times 6 times 10 to 3. This is the scientific notation. Scientific notation always, you have to put a number here other than 0, cannot be 0, any number different than 0, then the decimal point, another number, times 10 to the exponent. The exponent could be positive or negative, but this is the format of the scientific notation. Okay, any questions about this? All right. Let's move on to factoring. Now here we have x to the 4th and then 81, right? How can we do this? You have to convert this x into like this, 9 squared, all right? So 81 is 9 squared, and so now I have the difference between squares. I have converted this here into the difference between squares. Look, this is square of x squared is x to the 4th. The square of 9 is 81. Once I do that, then I just make x squared minus 9, and then x squared plus 9, okay? Now, the difference between squares is factorable. The sum is not, okay? So many students thought they could factor this, but that's only, it's not factorable. You have to leave it the way it is. This is the only one that you need to continue to factor. Remember, when you are asked to factor, you need to factor completely. You cannot stop here. Many students did stop here, okay? So let's do x plus 3, x minus 3, and then x squared plus 9. Okay, so that would be the final answer. Is that okay? Is that clear? So, things to remember. The sum between squares is not factorable. The difference between squares is factorable. Every time you see x to the 4th, you have to remember, oh, I can always convert that into the square of another square, right? X squared is the square. X to the 4th is the square of x squared, okay? So this way you can work with it. Okay? All right, so I'm going to erase this to avoid too much writing on the board. Erase this. And this. Okay? All right, so let's continue. So another example of a polynomial that needs to be factored is this one here. Let's see, what term we have here in common? I can see I have 3, 18, 27. I see that they all multiples of 3, so I can get 3 out of it, right? How? I can write 3x to the 4 plus 6x plus 9 x squared, right? Now, again, well, we're not used to work with this, but I could work with the square of that. If I make this guy here another variable, I call this x squared a variable y, then I can write it this way. Y squared plus 6y plus 9. And that looks more familiar to us, right? We can factor that. In fact, this is a complete square. Look, 9 is the square of 3, and 6 is 2 times 3, right? So this is a complete square. So I can write this like that, y plus 3 squared, okay? Now I can substitute the value of y here, so I can write 3x squared plus 3 squared, and that's it. Remember, I cannot factor this, right? This is not factorable. Is that okay? So always remember, when you see something like this, make sure you call this another variable, like y, and this is going to be y squared, okay? And then you can continue factoring. Okay, can I erase now? Is that okay? Okay, let's look at this one. 24, 6, and 45. And I see y, and y, it's a common term, so I can extract that out. Can I extract 6? Not really, because this is 45. Yeah, maybe 3. And this would be, yeah, I can extract 3 out of here. 3 and y. 3 and y, because y is common in every term. So if I do that, so 24 is going to be 8x squared. Here I'm going to have, what, 2x. And here I'm going to have a 15. Let's see, is this correct? 3y times this is going to be 24, y, and then it's going to be 6 here, and 3 is 45, so that's correct. So now let's see, can I factor these guys? Again, we're going to have 3y here, and then maybe 2x on this side, and then 4x on that side. Let's see. So 4, 2 and 4 is 8. That's one possibility. Now I know 15. When you want to factor this, this is, if I had 1 here, I would use the product and the sum. Because I have a number here different than 1, then I know I'm going to have to play that. I could have x times 8x. I could have 2x times 4x. They all will give me 8. I'm going to try this one first. Now here, the first 2 terms go to this one, and the last 2 goes with 15. I have a negative sign here, so the product of a negative, one of them is going to have to be negative, and the other one is going to be positive. So between 15, I have maybe 3 and 5. Now I see here, let's see, 3 times 4 is 12, 2 times 5 is 10, and I need a negative 2 here, so that looks like a good choice here. So if I put 5 here, and if I put put 3 here, so 3 times 4 is gonna be 12, this is gonna be 10. This one has to be the negative because a negative 2 and positive there. So now I see 2x times 8 is 8x squared, 2x times 5 is positive 10, then negative with 4 is gonna be negative 12, and then negative 15, so that's a good math. So that's how you got this one done. Is that okay? Okay, let me erase this, so I don't get confused. So the last one here, when I see cube, I know it's gonna be the difference between cubes. The difference between cubes, you have to remember this formula. So a minus b, a squared plus ab plus b squared, okay? If I had positive here, then I would have positive here, then this is gonna be positive, and the negative sign is gonna be there. So please make sure you remember this. But this is not completely a cube. 16 is not a cube of any number, but I see also 2 here. I see I can extract 2 by doing like this, x cubed minus 8. Now 8 is a cube of 2, so x cubed, 2 cubed. Okay. All right, so now the only thing I need to do is apply this formula. So it's going to be 2x minus 2, x squared plus 2x plus 4. Okay? So remember, whenever you see exponent 3, it's going to be some kind of, you're going to have to use one of these formulas, okay? And you need to figure out, the cube. 16 is not, so you extract 2 out, factor 2 out of here. So now you have 8, you can convert that into this, the difference between cubes, and then you apply that formula direct, okay? All right, so now let's move on. Let's move on to rational expressions, okay? So now we're gonna use factoring to some of this. Let's look at the numerator here. I can extract 2 out of it, so it's gonna be x minus 3. What about here? Can I extract anything here? Yeah, I can extract 2 again. So I'm gonna have 2x squared minus 9. Well, the difference between squares, I can factor there, so I'm gonna do that and see what happens. So I have 2x minus 3, 2x minus 3, x plus 3. Now, what I need to do, I just simplify this guy with this guy, this with this guy, so the answer here is 1 over x plus 3, okay? All right? So, this is the next step. After factoring, we're going to study rational expressions, okay? What about this one? What do you think? How do you think you're going to solve this? How can we solve this? This is an equation. Here is just simplifying, right? I just simplify. But here now I have an equation. So this part is equal to this part. So that means I'm going to have to solve it for x. Any suggestion? Yeah.
Would we start by factoring out the 1 in the middle?
Yeah, we could do that. So let's do that and see what happens. 3x plus 3, 5x plus 3, x minus 3 minus 2, x minus 3. So now, what else? What should we do? This looks like a fraction, right? What do we do when we do operations with fractions?
Find a common denominator.
How to find a common denominator. What is a common denominator here? What would be a common denominator here?
X minus 3.
X minus 3. But look, this guy here. It's like having something like this. Look, 1 over 2 equals 5 over 4 minus 3 over 2. What is the common denominator here? Between 2, 4, and 2. What is the common denominator? 4. So what is the common denominator here?
X squared minus 9.
Yeah? So this guy here is the common denominator. So what is missing here? What is missing here? Another 2, right? I need to multiply by 2. Here I need to multiply by 2. Here I multiply by 1. So here's the same thing. Here I need to multiply by x plus 3. And here x plus 3. Okay? So let's do that. I'm going to do that here. All right? So I'm going to have 3 x plus 3 divided by x squared minus 9 equals 5 x squared minus 9 minus 2 x plus 3 divided by x squared minus 9. Okay? So this here is x squared minus 9. Okay? So now, what do I do now?
Combine like terms.
I can get rid of the denominator, right? If I multiply both sides of the equation by the denominator, it goes away, right? But is there any restriction here? Is there any restriction here? Is there any value of x that is not possible? What value of x is going to make this equation, impossible?
3x plus 3
X,
plus 3. Look up over
what,
here.
what value of x is going to make this not possible?
Oh,
Yeah, 3, right? If I plug in 3 here, I'm going to have 3 minus 3 is 0. Is there another value?
Negative.
Negative 3. So x has to be different than negative 3 and 3. So there is a restriction, right? Restriction. So you got to be careful. When we solve this, if we find these values, so the problem has no solution. Is that okay? Okay, so because I multiply both sides by the denominator, so now I'm going to have 3x plus 3, 5 minus 2x plus 3. Okay, so this is all gone now, so I just need to solve this. So I'm going to have here 3x plus 9 equals 5 minus 2x minus 6. Let's move x to the left side, so I add, so I'm going to have here 5x equals, 9 comes to the other side, I'm going to have here 5 minus 6 minus 9, so 5x equals, this is negative 15, negative 10, so x is negative 2. Negative 10 divided by 5 is negative 2. So that is the solution, okay? That's how you solve this kind of problem. So remember, whenever you have rational expressions and you try to solve, make sure you check restrictions, right? What values of x, this is not going to work, okay? Of course, if I plug in x equal 3, this is going to be 0. A number divided by 0 is undefined. So there is no solution for that. Because we found x equal to negative 2, so that means we have a solution. So what that means is if I plug in x negative 2 here, this side is going to be equal to this side. Okay? Okay. So let me erase all this. So we move to the next problem. Okay. So now we have again a fraction plus a number, another fraction here. How are we gonna solve this? Again, we need to find a common denominator. What is the common denominator here? Between 2x and 3. What is the common denominator here? Anybody? What is the common denominator?
1.
What? Huh?
2.
2? If I have 1/3 plus 1, what should be the common denominator here? 3, right? Well, here I have a variable. What do you think? What is the common denominator here?
X.
X, right? I need to have X here, okay? What about this one here on the bottom? What is the common denominator here? What is the common denominator here?
X squared.
X squared, excellent. So now I have 2 plus X here, I have 3x over x, and here I have 4x squared minus 9x squared divided by x squared, okay? So now I have, a common denominator, right? So let's simplify that. So I have 2 plus 3x divided by x. Here I have 4 minus 9x squared divided by x squared. Okay? Now, how are we going to solve this now? Well, remember, what is this? This is basically one fraction divided by another fraction. How do we solve this?
Multiplying, like flip and then multiply.
Flip this one here, the bottom, right? Convert this division into a multiplication by writing 2 plus 3x over x times the reciprocal of the second one, x squared, for 9x squared. Okay? So now I see I can simplify this x with this x here. What about this here? Is this the difference between squares? It looks like it is a difference between squares, right? So this is 2 squared minus 3x squared. Isn't that this here? So that means I can further factor this. So this guy is going to simplify with this guy, so I'm going to have here x times 3x. And this guy here, now I'll be able to factor, is going to be 2 plus 3x, 2 minus 3x, okay? So I can, again, simplify this guy with this guy, so I'm going to have x, 2 minus 3x, okay? All right? This is good? Okay, so let me erase this now. Let's do another one. Well, this one here, this is not an equation, but it is a division here, and I'm going to have to simplify. So how can I simplify? The first thing I need to do is to factor each term so I'll be able to simplify. Okay? How can I factor this? Is there any way to factor this? So look at this and this, right? This is the product of the first two. So maybe it's 2x and x here. And the other one looks like is the product of maybe 1 and 9 or 3 and 3, okay? I see that the product is positive, but the sum is negative. So it means that both are negatives. And let's see, and looks like it's going to be 3. Let's try it, okay? So let's see. 2x times x is 2x squared. 2x times negative 3 is negative 6x. 3 times is negative 3, so negative 6 with negative 3 is negative 9, and the product is 9, so that's good, that's perfect. So now here, can I factor anything here out? Let's see. If I take 4 out, let's see, 4, I can have 2x minus 3. Let's see, is this correct? 4 times x, 8x minus 12, that's okay. Now here, I need to convert this, remember, division between fractions. I need to convert this into multiplication, and I flip this guy, so I'm going to do 2x on the numerator now, and I can factor x out, x minus 3. See, what can I simplify here? Let's see, what can I simplify? First, I can simplify this x with this x, all right? X minus 3 with x minus 3, and then 2 with 4. So what is left is 2x minus 3. Oh, I can simplify this also, look, beautiful. So what is left here is just 1 on the top and a 2 on the bottom, 1/2. Okay, you see how easy it is? Isn't that beautiful? Okay, this is it for today.